Okay, it says that Maria paints a rectangular wall and the length of the wall is 20.5 and the height is 2.4. Now we have a keyword which says that both correct to one decimal place. Why would you think they want to tell you this information? Okay, let's draw a rectangular wall first. Of course, you draw a rectangle and we know the length is 20.5 and this is 2.4, but it is correct to one decimal place. It means, for an example, for this case 20.5, let's say if I have 20.53 and I round this to one decimal place, I'm still getting 20.5. So you have to guess all the possible value which is within the bound. So when we do that for 20.5, I know the lowest that I can go is 20.45. You see, if I do rounding to one decimal place, I will still get the 20.5. And what is the largest that I could possibly go? Maybe 20.5 49999. In this case, if I round this to one decimal place, I'm still getting 20.5, but I know that this number is very much near to 20.55. So what you do, you have to put less than symbol here, so you get 20.55. You have to be careful, do not go and put less equal, otherwise you will be wrong. Similarly, for 2.4, what will you write? You're going to do 20.35. Try. If I round this off, I will still get 2.4 to one decimal place. Can you take 2.34? If you take this number and you round it to one decimal place, you are only getting 2.3, which is not the 2.4. So don't take it. Okay. And this side, it's going to be, we call it as upper bound, 2.45. Did I put the equal sign? No. So you have to be careful. Maybe I highlight this for you. Okay, done. But now what does the question want? They say 1 liter of paint can cover an area of exactly 10 meters squared. Okay, let's write 1 liter covers 10 meters squared. Okay, fine. Now we want to know, calculate the smallest number of 2.5 liter tins of paint that she will need to be sure all of the wall is painted. Now, how do I make sure that all of the wall must be painted? And there is a keyword that says smallest number of 2.5 liter thin. Okay, first misconception by student is they will do 20.5 times by 2.4. You cannot do this. Why? Because of this information here. They are saying both correct to one decimal place. Now, to find the smallest number of thin of paint, you must make sure that all the wall is painted, which simply means you need to find the maximum possible area of the wall. Maximum possible area comes from the upper bound, which is 20.55 and 2.45. Okay, let me explain. Now, let's say if you are choosing 20.45, it means the length is slightly shorter. Am I correct? See, this is 20.5, so I make sure I take something small. And then if you take 2.35, it is smaller than the height, slightly smaller. So when you multiply, what is happening? This is the area that you are covering. Okay, let me just make a rectangle for you. Like that. Are you covering all of the wall? No. Why? Because you have this tiny part here, the tiny part here that you are not considering. So of course you cannot take the lower bound. Now, when you take the upper bound, let's see what happened. I am taking 20.55, slightly longer than the length given. And then 2.45, slightly longer than the existing height. So when I do this, I know that I will make sure that all of the wall will be covered. Okay, let me color it. So what is happening? You are taking all of this. See, every part of it. So you should not do this one. Instead, you must do 20.55 times by 2.45. So let's find the area. What happens? We are getting 50.3475 meter square. But what are we looking for? We want to find the 2.5 liter tins of paint. So 1 liter is 10 meters square. 2.5 liter will cover an area of 25 meters square. Now what am I having? I am having 50.3475. So what you should do to find the number of tin, you need to do 50.3475 divided by 25. 5, which will give us 2.0139 tins. Can the number of tin be decimal? Of course you cannot. Will you now choose 2 tins or will you choose 3 tin? You need to take more than the 2. More than the 2. So your answer is definitely going to be 3.